Hello friends, welcome to our channel. In this video we are going to control the PMSM motor by using FOC control, field oriented control of permanent magnet synchronous machine. So this is the permanent magnet synchronous machine, and here we have the DC load for this particular motor, and here we have the inverter. So let us get into the controlling part. So here we have the input is given in terms of radians per second. So it is 100 radians per second. 100 radians per second corresponds to around 1000 rpm. So this would be our reference, and to this reference we are taking the actual speed, so by means of the encoder here. Okay, you can see the encoder. The encoder 1 is the one which is connected at the back side of the PMSM. Okay, so this yellow color wire represents the encoder 1. So the speed and the rotor position of PMSM will be sensed by this encoder. So after sensing this, the speed will be compared with the reference speed, and inside this we have the comparator, and the comparison will be done here, and the error will be given as input to the PI controller. So this is the proportional side, and this is the integral side of the controller. So this is the outer loop, and at the inner loop we have ID loop as well as IQ loop, current loops. So this is the ID reference. ID reference is 0 here, and that will be compared with the actual ID. So these two are the phase currents. We are sensing two phase currents, as you can see here. We are sensing the phase currents, and once the phase currents, two phase currents are being sensed, it is sent into the transformation ABC to DQ transformation, and here the transformation is done. From the values of A, B and C, we are calculating the values of D and Q, and here we have the value of theta coming from this encoder. Okay, so from the encoder we are finding out the angle. Initially the angle will be in terms of mechanical angle, and later it will be converted to the electrical angle. So P is the number of pole parts, poles, and it is divided by 2. So here we have VD and VQ coming, and the VD and VQ will be converted to ABC. So this is not based on SVPWM, it is based on PWM, sine PWM. Okay, so this is the conversion block used to convert DQ frame to ABC. So inputs are VD and VQ, and the outputs are VA, VB and VC. So all the three phase voltages will be given as input to the PWM generators, and these three PWM generators will be producing pulses for all three phases. And here we have the control logic for this DC load. So by varying this, we can vary the load actually. So this will be the actual feedback, and this will be fed back to the current will be sensed, and it is fed back to the the PI controller. So here it is compared, and error is compared with the error is given as input to the PI controller here. So here we have the PWM pulses coming out of this control. See, in this sample inverter box, actually you will find three inverters: inverter 1, inverter 2 and inverter 3. So here we are using the inverter 1 and inverter 2. Inverter 1 is used to control this PMSM, and inverter 2 is used to control the DC load. So let us run the simulation, run the model based controller now. So as you can see, it is building. And 80, 100. Yes. As you can see, the speed is settling perfectly at 100 radians per second. So when you press this, you can see the time getting changed. So the same model is available for download for free, and you can purchase this model also. So you can just click the link given in the description to purchase the kits. Okay, so it's a very good model actually. We can build our own control logic for controlling or for any other purpose we can use it. Even you can use it for your research purpose. Everything can be built based on our logic. So that's the advantage of this model. So thanks for watching.